Hello, I'm Dan Frith for Gestalt IT. You can follow me on Twitter at PenguinPunk. And today I'm joined by Tony Afshari from Pliops.
Hi, this is Tony Afshari. I'm the Senior Director of Product Line Management for Pliops, and we're thrilled to be here.
Can you tell me what Pliops does and what problem it solves?
Yeah, so at the highest level, we are here to massively accelerate performance and dramatically lower infrastructure lower infrastructure cost of flash-based data-intensive applications. And the reason for that is that software fundamentally is designed around a slower storage, and the pace of the growth and speed of storage has gotten so fast and so high in the recent years that uh, neither software nor really the CPU and the x86 core has been able to keep up with that. So there is a problem there with people not being able to take the full advantage of flash storage and its capability, and that's what we are addressing. And in the core of this is our technology, which consists of a half-white, half-length PCIe card and a storage processor inside there that combines multiple key data and storage technologies into one device that together multiply the benefits.
So, Tony, we frequently associate Flash with high performance, but we don't always think about its impact on infrastructure reliability in the data center. How is the Pliops approach different to what the traditional all-flash disk array vendors are doing in terms of reliability?
Great question. We do a lot of the things that they do, but we do it at a micro level. We do it in our chip, and we do it in an environment that is suited for cloud and the cloud building components, including servers, commodity servers, and inexpensive SSDs. We have the ability to make those SSDs behave really nicely and offer everything that an all-flash array does, including acceleration, data protection, encryption, etc., thin provisioning. So we do all of that, and we do it at a very, very high scale performance model.
So, can you take me through some of the benefits of Pliops' approach to drive failure protection? Does this approach only impact one server, or is it broader than that?
It's broader than that. So if the problem is solved within one server, it eliminates the server being out in a bigger cluster. So if a node is going down or a server is going down due to drive failure, and this is something that happens even with SSDs, that causes trouble for the operator, and that essentially takes that node out of a bigger cluster. So it takes that machine out of service, and depending on how dense the storage is in that server, rebuild time is very expensive for those scenarios. So if we can solve the problem of drive failure at the server level and be able to perform much higher than standard, let's say RAID 0 striping, which is the fastest striping there is, and be able to rebuild at the server level, at the drive level, with no performance hit, and be able to expand the capacity of the server, and in other words, even give more capacity to the user, then it becomes a very attractive solution to cloud and even enterprise applications.
So does that mean I can start to treat QLC as a more reliable storage medium in my data center?
You absolutely can. So even lower end TLCs and QLC, even ZNS drives become very easy to use in the scenarios you mentioned. But on top of that, it requires no changes to the application. It requires no changes in the integration. Even in the case of ZNS drives, we manage the zones in the background, but QLC is becoming very popular in this case because it's a media that is very attractive. It's the cheapest flash there is, but it comes with its expenses from a performance perspective. But we address all of that, and we also address any reliability issues or perceived reliability issues that QLC may have, because we introduced drive fail protection with QLC drive while improving the performance and addressing rebuild times, at the same time benefiting from the great items that QLC brings to the picture: massive capacity and lower cost.
That's interesting. So do you want to tell me more about that drive failure protection?
Yes, I can. So fundamentally, it goes back to the things that we do in the core of our IP. So we compress the data, and as a result, we create these variable size objects. And that's our specialty, to be able to manage these objects very effectively and add wire speed and be able to create these long strings of data that we can write to the SSD, to say even QLC SSDs, very effectively. In other words, make the SSD perform very nicely. So our data protection algorithm and our striping algorithm essentially comes at the end of that. So we've already made the data very manageable for the SSD. On top of that, we're adding our striping capability. So we write significantly less than a traditional RAID solution. And because we save so much space on the drive, we can even create what we call a virtual hot capacity without really taking user space away from them. So we have enough space now on the drive to be able to create a virtual hot capacity and not have to dedicate a whole SSD to that, and recover automatically through a rebuild that takes place very fast. And this also allows us to be able to recover from multiple single drive failures at a time.
That's awesome. So thanks very much for your insights, Tony. You can learn more about Pliops at pliops.com.